Hello everyone and welcome to another video. Today I'd like to continue our series of tutorials showing how to visualize the state of an aircraft model that's being simulated by Simulink. In particular, I'd like to look at how to use the free open source flight simulator FlightGear to perform the visualization of the aircraft attitude and position as well as rendering the surrounding environment. So, if this all sounds like fun, let's jump over to Simulink. Alright, so here we are back at our aircraft simulation model, and this is the model we developed in our last video where we showed how to visualize the states of the vehicle using Simulink 3D animation. So if you haven't seen this video yet, please watch it first, as I'm going to assume that you're familiar with what this model is and how it works. Now, the last time, we saw that this setup was pretty neat because you could actually fly the aircraft using either the joystick inputs or a set of control surface deflections from the workspace, and then render the orientation and location of the aircraft using Simulink 3D animation. However, we saw this was a little cumbersome and disorientating due to the poor camera angle of this particular 3D world. So, as such, the game plan for today is instead of using Simulink 3D animation to render the scenario, we want to send the relevant state information to another software application, namely FlightGear, and let it do the rendering/visualization. So, to do this, we are actually going to leverage another block in the aerospace block set. So if you come here to aerospace block set, animations, flight simulator interfaces, we're going to use the FlightGear pre-configured 6DoF animation block. So let's just go ahead and grab, drag, drop that into our model. And what we should probably do is let's open this block up and take a look at the block parameters. And what we see is that this block is pretty darn great, and it supports various versions of FlightGear. So you can see right here, FlightGear versions. So the first thing we should probably do is pick which one of these versions we want to use on our machine. So I'm just going to go with the latest. So for my machine, it's version 2018.1. So what we need to do now is go ahead and get this compatible version of FlightGear installed on our machine. Alright, so to get the FlightGear software, just go here to flightgear.org and it'll bring you to the home page. And again, FlightGear is a really great open source flight simulator. For our purposes, if you remember, we're looking for version 2018.1, so I'm going to come here to download. And here you can download the latest versions, and if you look here, it looks like this is actually a little bit newer. So just to be on the safe side, I'm going to go get exactly the version of FlightGear that was mentioned in the Simulink block. So to get older versions of it, again, depending on when you're watching this video, the interface may have changed, but hopefully you should be able to come down, and at some point you should be able to go to find the source code. So I'm going to go here to the source code download page. And I'm going to scroll a little ways down. I'm looking for, here we go, historical material. There should be something about archives. And I'll pick one of these mirror sites, maybe mirror number 1. And it brings you to this page. And on first glance, it doesn't look like it's got the versions that I'm interested in. But for whatever reason, if you go up a directory, so I'm going to hit the dot right here to go up a directory. Now, here we go. Now I'm looking for, what do we say was released 2018.1. I think that's the version we're looking for. So I'm going to click on 2018.1. And I'm going to pull down the exe. I'll download that, and I'll give this a second to finish. You can see it's quite a big file. And we'll be back in a second. Alright, so it looks like that download finished, so let's just go ahead and double click the exe to start the installer. Okay, and here we are at the setup, so let's go ahead and accept the agreement, hit next. Oh yeah, you might have to disable antivirus during your installation, but let's hit next. Yeah, I'm going to go ahead and install it in the default location. Again, keep in mind, this is a pretty big file, so it looks like it takes, 2.5 gigs of disk space. So I'll go ahead and hit next. Next, I'll create a desktop icon, sure, why not? Next, and let's just install. And we'll give this a couple minutes to get finished. Alright, so it looked like it finished installing FlightGear, so let's just go ahead and click Finish to exit the setup. Alright, so now that I've finished, we should have now FlightGear available. If we just come look in our applications, here it is. Yep, FlightGear 2018.1. So let's just go ahead and fire it up to make sure it works. And give this a second. And yeah, I think the first time it's going to have to import some artifacts. Alright, and it looks like it launched. So, let's head back over to MATLAB for a second. Alright, so now that we've got FlightGear installed, I think it's time we take a closer look at the block. And first, maybe what I'm going to do is I'm going to turn the block name on so it just stays on all the time. Okay, so let's take a closer look at the FlightGear pre-configured 6DoF animation block. So I'll just double click to bring up the block parameters, and we can see Couple of things. So again, we talked about the FlightGear version. So this is the version of FlightGear that we just installed. Now, since we're going to be running FlightGear on our local machine, this is the correct IP address. This does have the functionality that we could be running FlightGear on a second machine, and then we could send the packets to a specific IP address. But to keep things simple, let's keep it all on one machine just to minimize the potential things that can go wrong. Again, here's the port that we're going to be using, and we can leave the sample time as the default 1/30th. Now, let's go ahead and read the help documentation. So I'm going to click on help here and drag over the help documentation for this block. In particular, what I would like to understand is what are the inputs here. So you see that there are 6 values that go into this. And if we read the help documentation, it says the input is a 6-element vector, which is basically the longitude, latitude, altitude, roll, pitch, and yaw Euler angles. Now, a couple things we need to note here. First of all, the units for the longitude and the latitude, if you notice here, they are in degrees. However, I kind of think this is a typo. Let me zoom in a little bit. Maybe we can see this a little bit better, and we can see what I'm not super happy about. This word here, west. I think actually most longitudes, they're actually positive east. So if you have a positive 14 degrees longitude, that means 14 degrees east. This, I believe, should be the word east. Okay, so that's the only thing I think that is a slight typo. Let's keep that in mind as we move forward. But long story short, the longitude and latitude are in degrees, and then the altitude is in meters, and all of the attitudes for these Euler angles are all are in radians. Okay, so that's helpful information. So what we need to do now is we need to start thinking about, let's generate basically a mux, and I think I've already got part of this configured. And let me go ahead and paste this over here. Whoops, sorry. Hold on. Delete that. Oh no, sorry. This is a little bit messy. I wanted just this mux here that I pasted in from another model. Okay, so here we go. So this is the appropriate inputs to this block. So again, what are coming in here are, this should be, I think we said this is longitude in units of degrees. This is latitude in units of degrees. Then we had a third input was altitude in units of meters. And then the 3 Euler angles. So we had the bank angle, or phi, in units of radians. And then we had theta in units of radians. And then finally we had psi in radians. Okay? So the game plan now is basically we need to go ahead and hook up the appropriate signals. So if you look at our model, with most of our aircraft models, we already have phi, theta, and psi, right? Those were the 3 Euler angles. In fact, they're right here, phi, theta, and psi. However, we don't have longitude, latitude, and altitude with the current model. I mean, I guess we kind of have altitude. Altitude is sort of the negative of position down right here. So we could just put a -1 in there. But to get longitude and latitude, we're actually going to need to insert our navigation equations as well as our geodetic position calculation. So luckily, I already have that prepared off screen. Let me go ahead and copy and paste that in here. Whoops, there's that. Let me move this and reposition it a little bit. Okay, so these are the navigation equations, and this, again, the navigation equations, if you remember from our previous lecture, we discussed how these equations came about. They basically transformed the velocity in the body frame, which was UVW, and they transformed that into velocity in the northeast down frame, which is velocity north, velocity east, and velocity down, or negative altitude dot, however you want to think about it. And then from there, we were able to take that, and using our geodetic position calculations, again, we had another separate video discussing exactly what goes on behind this block and the equations behind it. So this is going to allow us to calculate geodetic position. So all we need to do now is wire these up. So the only thing that we got to be a little careful of is, let me wire this up first. I think in our previous lecture, we made it so that this output is a 3-element vector of latitude, longitude, and then altitude. So you can kind of see that immediately right away there's a little bit of a mismatch, in the sense that out of this is latitude in radians, and then coming out of it was longitude in radians, and then finally altitude in meters. So we see that there's a little mismatch. I can directly hook up the altitude. That's no problem there. Okay, but there is a units mismatch as well as a ordering mismatch. So what I need to do here is I actually need to let's get ourselves a gain block here, and we're going to convert from radians to degrees. All right, that's what this calculation does. So I'm going to get this guy in degrees. I'll copy it down here, get this in degrees. Let me scoot this over to get us a little bit more real estate. Okay. And now what we need to do is latitude is actually down here, right? It's the second input. And then longitude is up here. There we go. Okay, all right. And then let me see. Phi, theta, and psi, we already had those. Those were up top. So again, this is getting a little messy. I'm going to scooch this over so we can get phi, theta, and psi connected. So where was phi? Phi was our Euler angle up here. Okay, so that's this signal here. So I'm going to branch off, connect up phi, and then where's theta? That's this signal. So branch off, connect him. And finally psi, our last Euler angle, was this signal here. So branch off, connect him up. Great. Okay. Oh, and then I guess I got to give the state vector to this block. All I'm doing in this block, you can see it's just a demux. I'm just pulling off the body axis velocities and the Euler angles. So then I can pass those 6 inputs into my navigation equation. So at this point, I think we actually have all of this connected up hunky-dory, and it's almost ready to go. So right now, the model, let's just walk our way through it. And maybe I'll flip this switch to go to the joystick. So again, I think we talked about this earlier about what this joystick is doing, but I'm basically reading in a joystick input commands for the control surfaces. I'm then running it through our aircraft plant model, the RCAM model, and then I am sending the relevant information basically to FlightGear. So the next thing we need to do is we need to get FlightGear ready to accept this data that we're going to be sending from MATLAB and Simulink. All right, so I've started the FlightGear launcher, and what we need to now do is get it ready so that it launches FlightGear in a mode that is ready to accept data that's coming from Simulink. While we've got the FlightGear launcher in the default state, I want to call your attention to the fact that the default location is Honolulu International Airport, PHNL. Let's just make a note of this, as we'll come back to this later. Now that being said, let's get back to the task of getting FlightGear ready to accept data from Simulink. So one way you could do this via the launcher is you could come here to the settings menu as category, and down here in additional settings, you could try to enter in all the necessary command line arguments to get FlightGear to start up once we launch it via this launcher, and get it to start up in the appropriate configuration. Now, while that's feasible, it's not really too user-friendly and practical. There's a lot of ways you can make mistakes. So actually, I don't think this is the best way to go. So I'm just going to close the launcher. Lucky for us, MATLAB Simulink makes this really, really easy. So I'm going to go and start up my Simulink library browser. And again, I'll come here to Aerospace Block Set, Animation, Flight Simulator Interfaces. And again, here's the block that we were just playing with, right? This was our FlightGear pre-configured 6th-off animation block. Well, look at it. Right next to it is this block called Generate Run Script. If you drag this into your model, and let me, again, I'll turn on the name just so we know what we're talking about. So I'll say show block, whoops, come on, where did it go? Format, show block name on. Okay, so this is the generate run script, and it's not even really a block, it's a script. If you double click on it, you see what you get is you get this dialog, which is going to help you set up a script that will launch FlightGear in the appropriate configuration. So let's just walk down through this, what's appropriate. So target architecture, I'm on a Windows machine. Yep, I want to be sending data from MATLAB to FlightGear. I don't want to click this button yet. I'm not ready to generate the script. Let's come down here. Okay, FlightGear geometry model name. So this is basically the aircraft that we're going to start FlightGear with. So right now it's got this NASA HL-20 vehicle, but that's not actually what we want. So to figure out what we want, let's open up a Windows Explorer. Okay, let me put some of these side by side. So I'll open up a Windows Explorer, and I'm going to come here to see, where did I install FlightGear? That's the other thing I need to know. I think it was in Program Files, And then, here we go, FlightGear 2018.1.1. Open this guy up, and then come into your data, and then aircraft, and this is all of the aircraft that are installed. So right now, there isn't an HL20 vehicle or definition installed, so this is not going to be terribly helpful. So what I want to do is I want to pick a vehicle that's already installed. So for example, this Cessna 172, I'm just going to copy the name of the folder. So lowercase c 172, lowercase p, and let's paste that in here. Okay, great. Okay, airport ID. Looks like we're starting off. This script is going to start us off at San Francisco International Airport, KSFO, at this runway, at this altitude. And you know what? That's fine, because actually nobody really cares where we start off with, because if you think about it, right, coming back to our MATLAB Simulink model, as soon as this thing starts running, we are going to warp the aircraft to whatever longitude and latitude and altitude and orientation that the Simulink model is setting at, right? So I really don't care where the launcher starts me at, because we're not going to stay there long at all. So let's just, yeah, sure, leave it at KSFO. Who really cares? Okay. This one down here, install FlightGear scenery during simulation. I'm actually going to leave that unchecked, because I really want to understand what's going on, and we're going to talk about installing FlightGear scenery later, so I'll leave that unchecked. However, I definitely want to check this one where I'm going to disable FlightGear shader options. I've noticed that if you don't have this button checked, and you allow it to start up FlightGear with full shadering and rendering options, it's actually frozen on my machine several times. So this is a much better way to get around these hang-ups. So I would make sure that you have this thing checked. Okay, then let's come over here to network. Okay, network, again, this should look pretty familiar. Here's my IP address, here's the port, and again, we kind of want to make sure that that matches the block parameters here. Whoops. Can I open both these at the same time? There we go. Okay. Okay, so again, the IP addresses, yeah, that matches. The ports match. Okay, great. And let's come over here to file. So here's the name of the output file. It's going to make a batch file for me to run called runfg for FlightGear.bat. And then we need to tell the FlightGear base directory. Well, let's come back to my Windows Explorer where we are looking at that, and I need to come up to this level here. So here's the base directory. So I'm going to go ahead and copy this and paste it into this dialog over here. Let me cancel this one out. Let's come over here. Okay, so here's my base directory. Okay, paste. Okay, and then if I hit apply, I think this is ready to go. So let me come to my MATLAB working directory. Where am I actually working in right now? I think I should be over here. Yep, okay, so let me copy this working directory into the Windows Explorer just so we can see what's going to happen. Okay, so I've got that thing ready to go, and then let's bring up my little window here for the generate script block. So when I click this button, hopefully it makes something called runfg.bat, and hopefully dumps it in my current MATLAB working directory. So let's give it a shot. Okay, generate script. And there it goes. Here we go. Runfg.bat. So this is the output. If I look at this guy, let's right click and check it out in Notepad++. You can see what this is doing is it's setting all of those advanced options of how we want to start it, getting it ready to listen for the packets coming from MATLAB Simulink. So this is great. This is the file that we want to use to run our simulation. So let me go ahead and hit OK on the Simulink model dialog box. And then what we can do is, yeah, let's give it a whirl. Let's just double click on this bat file, and what that should do is, again, it should start up FlightGear in the appropriate configuration. So I'm going to go ahead and double click on this guy, and we get this coming up. Whoopsie, sorry, I dragged that over. Okay, great. Oh, look at that. See, it started the FlightGear launcher. Maybe we can kind of put these two next to each other just to see what's going on. And hopefully what we should do, if we give this a couple of minutes to boot up, it should start FlightGear with all the necessary settings, and it should just be paused, sitting there waiting at above, San Francisco, ready for the simulation to run. So let's give it a second. Yep, what's it doing? Loading scenery, yeah, electrical systems initialized. Okay, great. Oh, and here we go. Look at this. So it says everything's paused, and we're just sitting here, nothing's moving, and also notice that you can't really see anything. There's no there's no terrain right now. And the reason why is, if you notice, remember we called out earlier that I think the FlightGear launcher wanted it to start us over Honolulu. So I think it only has scenery probably installed for near Honolulu. So above San Francisco looks like there's no scenery, which is fine. So it's basically sitting here waiting for us and waiting for Simulink to send us information via this via the FlightGear preconfig 6DOF animation block. So why don't we get our model ready to run? I'll come back over to MATLAB and let's go ahead and initialize it. And notice here, what I'm doing here is I'm going to, hold on, Control Z. Sorry, I grabbed and dragged incorrectly. I was trying to highlight these two. So, like we said earlier, FlightGear has scenery probably default loaded over Honolulu, right? That's where, when we first installed FlightGear, it wanted to start us over Honolulu. So, you know what I'm going to do? I'm going to warp the aircraft to Honolulu. So, here are some coordinates for above Honolulu International Airport. So let's run this initialization script, which, it should have initialized everything and basically got this thing ready to run. So let's take a look, make sure this all seems reasonable. Yeah, I think we got this setting to the joystick. So we should be able to fly with the joystick in the loop. And yeah, it should send all of the data through over to FlightGear. So tell you what, let's go ahead and see if we can get this thing to run. All right, so actually, tell you what, let's pull up one of the scopes as well. Let's pull up the inputs from the joystick scope. So that's over here. Sorry, I pulled up on another screen. I'm trying to drag this over. Let's put this on one side, and then here's our model. And then what we want is let's get the FlightGear interface. Let's see if we can, let's see how crowded we can make this screen all at once. Okay, so I think we're ready to rock. So let's give this a try. I'm going to get my hand on the joystick. And now if we come over here and hit play on the Simulink model, hopefully give it a second to hopefully compile. And oh no, whoops. Oh, okay, sorry. I know what happened here. This is actually an interesting error. It's basically telling us that there's already a set pace block in the model. So we can't actually have two. So what the problem is let's come back over here to the Simulink model. Remember we talked about this block up here where it says set pace, right? This forced Simulink to execute in real time. Well, interestingly, if you come here to this pre-configured FlightGear model, this is actually a mask system. So if I look under the mask, here, we can see that basically here's another simulation pace block. So it's already built into that block. So when you drop in this FlightGear pre-configured 6DOF animation block into your simulation, it is going to force the system to run in real time, which makes sense since you're trying to send it to a flight simulator for visualization, right? So since we already have this block here, we can't have this other block way up here. So let's go ahead and delete that. Okay. And now, unfortunately, we got to get everything set up again. Let me pull up the scope. Let me pull up FlightGear. Let me move this a little bit up like such. Okay, let's give this another whirl. All right, go ahead and hit play. Bring a flight simulator up. And hey, look at this. Look at this. We're rolling. Uh-oh, what happened to our scopes? Where did the scopes go? Over here. Here's our scopes. Oh, and look at that. The scenery just popped in. Check this out. Isn't this cool? We're flying over Honolulu right now. So I'm going to take it into a right turn, kind of come around the bay, check out Waikiki and Diamond Head. And now here, I'll tell you what, let's do a barrel roll. Do a barrel roll. Woohoo! Oh, whoa Nelly, there it goes. Okay, and then come back and let's flip it the other way. Let's flip another. Oh no. Flip another barrel roll. Come on. Ah! Isn't this cool? So we're flying over Honolulu right now, using FlightGear as the visualization package, right? So this is pretty darn awesome. Whoa, no, there goes the mount. Oh, and I just crashed, but that's okay. This is too much fun, right? Okay, so this is working. Let's talk about maybe some additional scenery now. All right, so now that we've got this working, the world is literally our oyster. We can go anywhere we want. We can simulate and fly wherever. So, for example, remember here in our geodetic position calculation, the initial geodetic position that we were using was over Honolulu because that's where we had scenery loaded into FlightGear. But let's go change that. So I don't necessarily want to fly at Honolulu, so let's comment that out. And I've got actually some other coordinates set up. So these are some coordinates above Boeing Field in Seattle, Washington, in the United States, kind of near where I am. So let's see if we can just basically rerun our initialization script and now run the model and bring up FlightGear, and we are theoretically now flying above Boeing Field in Seattle, but this doesn't look right, huh? This looks like a whole bunch of ocean. And the reason why is because we don't have that scenery loaded in FlightGear. So let's talk about loading some scenery for wherever you're located in the world so that you can basically put your aircraft flying above whatever city you want. All right, so to do that, let's go and first exit out of FlightGear. We'll quit. All right, then we're actually going to come back to the FlightGear.org website, and we're going to come to the download section, and we're going to be looking for sceneries. So here we go, download scenery. Let's click on download the latest world scenery. And again, there's a couple of versions. I'm going to get the nicer one, the version 2.0. So here we go, download 2.0 via the graphical interface. Yeah, because I don't want the entire world. I only want data and scenery over the region that I'm interested in. So here we go. We can click on whichever region we want. So I wanted the Seattle Pacific Northwest region of the United States. So it's right there. So let's click on that. And wha-bam, it's going to start downloading. So let's give that a while to finish downloading. And we'll be back in a second. All right, so that download finished. Let's go ahead and take a look at it. Here it is. Here's the file. It's a zip file. Let's go ahead and extract all of these files. Okay, so I'll just hit extract. Okay, and while that is extracting, let's go and open up another Windows Explorer. And come here to C, and then let's go find, where do we have FlightGear? It was in Program Files, FlightGear, Data. And then we are looking for, here we go, scenery. Okay, and we'll get this ready. And as soon as this thing finishes unzipping, we'll take a look at this again. All right, so the extract/unzip finished. So let's take a look inside this folder, and we see that if you compare the two of these, they look really darn similar. So all we're going to need to do is basically, let's go here in the objects. So these are the new objects for the new scenery, and let's come here to our FlightGear database in objects. And all we're going to do is let's just literally copy over the new scenery, or the new objects here, into the FlightGear directory. And I guess I'll need administrator rights, so luckily I have those on this machine, so I'll say OK. And let's go back up and do the same for the terrain. So here's the new terrain, and let's come see where we want to put that as soon as this copy job finishes. Sorry, this is taking a little longer than I would have expected. Come on. 5 seconds. Yeah, this goes slow for some reason sometimes. Okay, tell you what, let's find the location. So here we go, terrain. Okay, so great. Here's my new terrain that I want. So again, let's copy the newly downloaded terrain, and we'll paste that into the existing FlightGear database. And again, we'll need administrator rights, so let's say yes. And all right, we'll give this a second to finish copying. All right, so our new scenery is now in the right folder, so let's go ahead and close these. We don't need them anymore. And let's come back to our batch startup file, right, that MATLAB created for us, and let's run this again. And we'll get FlightGear booted up and see if now, when we go to that new location, if the scenery is uploaded. So while this is booting up, let's go ahead and start up, come back to MATLAB. Again, here's our initialization script for all the variables. And again, here is our coordinates for Boeing Field in Seattle, Washington. So I'm going to go up here and hit run just to initialize the variables. Okay, everything is hopefully ready to rock. So let's come back and check on the FlightGear startup process, and it's still going here, but hopefully that should be done oh, actually, there it is. Okay, it's done. So again, here it is above San Francisco, waiting for inputs. So if I go ahead and start the Simulink model, let me maybe scoot that off to one side and put FlightGear on the other side, like such. Okay. So now let's go and see if this is going to work. So let's go ahead and hit start. And now we're flying. Give it a second. There it goes, and the scenery just popped in. Here we are. So this is above Seattle and Boeing Field. I think I'm heading toward the city now. I think I just am overshooting the area. There we go. Yep, there's Puget Sound. So this is looking great. So we've got the scenery all updated and ready to rock. Let's come here, and actually I want to show you one other cool thing. Let me pause this. The simulation. So as again, you can see we paused the Simulink model. A couple other interesting things you can do. So for example, we don't have to sit here in this cockpit view all the time. We can come actually here to say view. Oh, actually, before I do this, I should mention sometimes when you do this warping from one location to another, from like, you know, Honolulu to SeaTac or something like that, you might, the screen might appear completely dark. I think that's because FlightGear is actually trying to be smart and does something about like the time of day and the environment. So if the screen is all black, you might have warped to a location where it's actually night. So to change that, come here to environment and you say time settings, and you can click on say like noon, morning, dawn. So I don't know, click on morning, and you can see it's going to roll the clock back. The lighting might change and it'll get a little bit brighter, and hopefully that will fix any issues if you warped yourself to a location where it's night. So back to our discussion about the view. So I'm going to click on view, and what you can do is you can say adjust view position, and let's back this up a little bit. So let's move this behind. There we go. There we go. So now we're behind. So now we've got a chase plane view, and if I run this, whoa, Nelly. Oh, sorry. Hold on, the simulation was still running. Let me hit run again on the Simulink. There we go. Now, look at this. See, oh, there's Boeing Field right beneath us, right? I'm flying right over Boeing Field. And yeah, here we go. Now we're flying where we want to be. All right, now that things are working quite smoothly, now would be a great time to talk about some additional resources in case you're interested in exploring further. So MathWorks has some great documentation at this website. I will go ahead and leave a link to this URL in the description of this video. But it shows, again, how to use, actually MATLAB has a demo of this type of interface with the FlightGear interaction already packaged with it. So if you scroll down a ways on this webpage, you'll see, here we go, here's some examples. In fact, here's the command that you can enter into MATLAB. It is, what is this? AS, let me see if I can just copy this, the whole command, ASBHL20. If I just come over to MATLAB and type in ASBHL20 and hit enter, it will start up a project and will basically open a model that already has the FlightGear interface built in. So if you don't already have your own aircraft model and you just want to get something working real quick, you can go ahead and run this example, and it will load up this aircraft model with the FlightGear interface that you can use to explore this workflow as well. So with that being said, let's jump back to our particular aircraft and see if we can make this a little bit more interesting. All right, just for fun, let's see how complicated we can make this, and let's open up this VR Sync. Remember, this is our Simulink 3D animation rendering of the aircraft, so I'll double-click on that and drag that over so we can see. Okay, whoops, no, I don't want the whole thing. I just want a small box up there. Maybe let's see if we can give these a little bit more equal real estate. Okay, so there's FlightGear on the bottom. Here's our Simulink 3D animation on the top. And we've got the joystick running. So again, this is our Frankenstein flight simulator where we've got multiple views of what the aircraft is doing. Let's run this and see what happens. Okay, and see if it can handle it. Oh, yep, looks like my computer can handle it. So there we go. So here's a nice way to compare and contrast the two visualizations. And I think you'll agree that there's no real comparison. This FlightGear interface is a lot nicer, right? And it's a lot more intuitive of what's going on with the aircraft. Remember earlier, see you can see how that viewpoint of the Simulink 3D animation is a little bit non-intuitive of what's going on. So right now, yeah, see, I don't know what that viewpoint is doing with the Simulink version, but I believe this FlightGear interface, and it looks a lot nicer. So anyway, I'm going to fly this around for a little while, and I hope you enjoyed the video, and if so, I also hope you'll consider subscribing to the channel. We're going to have more discussions. In fact, the immediately following video, I think we're going to try to see, can I even do this with another flight simulator system such as X-Plane? So there'll be a couple of ways you can visualize the state of the vehicle. And with that being said, I think this is a good spot to leave it. I hope to catch you at one of our future videos. And until then, I think I'll sign off. I'll talk to you later. Bye.